Hello everyone, welcome back to the channel. I hope you guys are doing really amazing, and I will be giving the solutions of the easy problem in the post section, okay, of YouTube, and medium and hard questions only I will be posting from now on in the videos. Okay, so let's see. Although today's problem is a marked medium kind, but I will say that it is pretty easy. So let's see the problem statement today and try to discuss its solution. Okay, so check if a string contains all the binary codes of size k. Given a binary string s and an integer k, return true if the binary code of length k is a substring of s, otherwise return false. Okay, so if what they want to say is that, let's say you have this string s, which is nothing but 0011. So let's try to write it. They gave a string s, which is nothing but 0 0 1 1 0110. Okay, if you have this string with you, and if you try to right, so you have a k equals to 2. So it means that string of length 2, you want to find all possible binary sequences. What does binary sequences mean? So if you are given just 2 bits, how many binary numbers can you form? So using 2 bits, definitely 2 to the power 2 binary numbers you can form. That will be 4. So, and those numbers are nothing but 00 01 10 11. So if k equals to 3 would have been given, you know that 2 to the power 3 is 8, so there would have been 8 binary sequences which you can form. So it is something like this. Okay, uh, I hope it is very clear what they want to say. And they also want to tell that all of these binary sequences, all of these 4 sequences must be a substring of s, then return true. So if all such sequences, uh, if all such sequences are substrings, then what you need to do? Return true. Return true. Okay. So if you try to see for k equals to 2 and s equals to this, if you try to see, you have your 0 0 over here, you have your 0 1 over here, you have your 1 1 over here also. Okay. And you have your 1 0 over here. Okay, so you see that all the 4 types of strings, you actually get this in this number, and hence you have to return true. Okay, so I hope this was very clear and this is not at all difficult. And so the thing is that if you try to think in a very brute force manner and try to generate all possible substrings, so if you try to do something like this, generate all substrings. Okay, so what time will that take you? You know that ck is less than 20, right? So all substrings will be 2 to the power 20, 2 to the power k. Okay. So 2 to the power 20 is nothing but 1e6. This is of the order of 1e6. And out of all these substrings, you need to check whether they lie in the string or not. Okay, they are substring or not. So for that, again, you need, for each of them you need to check whether it is a substring, which will again take O of n time. So total time complexity will be O of n into 2 to the power k, and n is 5, 1e5. Okay, and you see that 2 to the power k was 1e6, so that will give you an O of 1e11. Okay, and this O of 1e11 will definitely give you a TLE. Okay, so I hope you do understand that you cannot just generate all the substrings. You need to find something else. In fact, if you just notice that, uh, see, if you are given a k length, then all the substrings, if you go through all the substrings, okay, if you go through all the substrings of size k, so go through, the idea will be to go through all the substrings of size k. Okay, so let's see. Let's take the example which is given only 00 11. What was this example? 01 10. Okay, in this example, if you try to write all the substrings, okay, of size k, so k was 2, try to generate all the substrings. So you see, you get 0 0 for this, you get 0 1. So using a sliding window of size k, if even it was 3, you could, using a sliding window of size k, you can easily find in O of n time only, you can easily find all the possible substrings. Okay, I hope that will be simple. So 0 1, again you slide again the window, you get 1 1, again you get a 1 0 with this, again you get a 0 1, you get 1 1, you get 1 0. Okay, so you see, you get 7 total substrings, but out of these 7 substrings, how many are unique? You try to see, this and this are duplicate, this and this are duplicate, this are duplicate, this is duplicate. If you try to see the unique substrings only, there are only 4 of them, and that is precisely what you want. Okay, that is precisely what you want. So all, if you generate all the substrings, okay, if you generate all the substrings, and the number of unique such substrings of size k, so number of unique substrings of size k, number of unique substrings of size k should be equals to 2 to the power k, right? And this you can easily find, how can you easily find the number of unique substrings? You can store them in a set, right? And you know that if you give duplicate values inside duplicate values inside a set, it will just not count that. And you can just see that if set dot size, if your set dot size is equals to 2 to the power k, it is as simple as that, and you can write a simple 4-line code for this. Okay, I hope you do understand how you will write. It is very simple and very easy to code out if you just understand that. So what you can have at first, have an unordered set of string, okay, and this will be set. And while iterating, you can just have something like this. Okay, so you are having a sliding window, right? I to I plus k. And you can use the substring function to generate the substring and insert it into the sets. Okay, so set dot insert is nothing but s dot substr. You know how the substring function works. The first argument, it takes the index, and the second argument, it takes the length. Okay, so I want, starting from the index I and length k, I want to generate a substring. Please generate it for me. And yeah, I have it. And if you just return s dot size is equals to what will be this thing, s dot size should be 1 2 to the power k, right? Is nothing but 1 left shift k. I hope you know this. And yeah, that is all the solution for this problem. You can just simply try to run it for few test cases first. You see, it got accepted, and if you try to submit it, I hope it will also pass with a decent runtime complexity. Yeah, so you see, the complexity was pretty decent. Yeah, I directly use the substring function because yeah, not much of constraint is there over here. You can also use a sliding window. I hope that will also work pretty well. Yeah, so yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.